Today we are going to be going over an easy integral, and then I'm going to show you an integral that I found for my homework that I think could be very educational for you in your integral research. So let's get straight into it. This is the integral on the domain of infinity to 0 of e to the power of negative 5x dx. Now, in terms of integration, this is pretty easy, but it's still a good habit to do it off to the side. I don't know where my cursor is. There it is. So e to the power of minus 5x dx is just going to be minus 5e to the power of minus 5x plus c. That's the integrand, so we can literally just plug it in. However, what you need to understand is that improper integrals need to be treated like limits. So recall that limits, limit process, and evaluating limits is a skill that you would have learned inside of Algebra 2 or pre-calculus, where basically, let's say I have a graph and it's like this. Where are these going to go to? Are they going to go to infinity? Are they not? If there's a graph that's exponential and it goes down here, like what's the area under this curve? Well, that's calculus. But like what's the end height? How tall is it going to be at the end of its slope? Is it going to approach an asymptote? These kinds of questions we can evaluate either algebraically, or we can use something called L'Hopital's rule. L'Hopital's rule states that if you have a function of x over a function of g, the limit of that function is the exact same as the derivative of the top over the derivative of the bottom. Now, that is useful when functions become discontinuous, which basically just means they can't be divided by 0. They can't have infinity times 0, and it can't be infinity over infinity, or infinity over negative infinity, as that would be discontinuous. We don't know what that is. If you do, make sure to comment it down below, because if you do, then we can forget about all of this and just evaluate them normally. However, I don't, and you probably don't know either, so this is the rule. We're not probably going to have to use this when you're using integration. Most teachers aren't very rude to you and make you use L'Hopital's rule in the middle of you finding an improper integral. However, if you do need to do it, then you have to take the integral and then you have to do some magic to apply L'Hopital's rule. However, you can't apply it unless it is 0 over 0 or infinity over infinity. If it's 1 to the power of infinity, 1 to the power of, not 1 to the power of 0. If it is, let's see, e to the power of 1 over 0, then you have to do something else. You have to do something called logs, and that is for another time. Anyways, back to this integral. So what we are going to do is we are going to simply find the indefinite integral, which we already have found. Put that thing in the way. Whatever. Minus 5e to the power of minus 5x. Let's see. And what we're going to do now is we're going to get infinity and store it in a variable, which is going to be b. b is equal to an infinity. So what we can do is say the limit as b approaches infinity from b to 0 is going to be equal to minus 5e to the power of minus 5x minus 5e to the power of 0. This is going to simplify to b and 0 minus 5e to the, oh shoot, that should be b, not x. 5e to the power of minus 5b plus 5, because e to the power of 0 is 1, and 1 times 5 is 5. So, as this approaches infinity, this is a function that we're going to try to evaluate the limit. And we can either evaluate this just with looking at our eyes, or using L'Hopital's rule. But L'Hopital's rule, again, wouldn't work in this scenario. So, it would be kind of like makes sense to say that this approaches infinity because it's an exponent, it's going to infinity. However, This is negative 5 over e to the power of 5b. And I don't know why I said that like that's bad news. That's actually good news. Because that means that as this approaches infinity, this is just going to cancel out. Oh. Yes. Because this is going to become a huge term, and this is going to become nothing. So it's going to cancel out to 0. And this is going to become 5. That's wrong. That is wrong. So I just led you guys all on the wrong path. If somebody just clicked off of this video, then I have no clue how they're going to do this correctly. So this is wrong, and now I'm going to perform what I like to call looking for an error. So the limit as b approaches infinity, that's correct. The integral of minus 5 to the power of e. Using chain rule. That's the derivative. Integral. Yes, I'm looking up the integral. Don't judge me. This is not a part of the problem. Okay. So you actually need to use something else. I think this is a u sub. This is a u sub moment. Yeah. Well, the derivative is minus 5 e to the power of minus 5x. That is what's wrong. I took the derivative instead of taking the integral. So removing all our work, sadly. The integral of e to the power. So we had the right idea. We just. I think this is an integration by parts moment. I would set whatever I want to derive to u and whatever I want to integrate by v. So u would be equal to e to the power of minus 5x. du is equal. This is a whole other thing, but it's like it's a whole other thing, but hopefully you know what I'm talking about. dv equals dx, v equals x. This should be it. Wait, u, du, dv, v. Okay, so e to the power of minus 5x minus integral of x and it seems like it's worse. You'd really think that this is actually like worse, but it's not. Or is it? This would simplify back to this. So this is not integration by parts time. What? Can I not integrate this? What is going on? Determine whether the integral is convergent or divergent. If it is convergent, evaluate it. Did I place it as divergent? Okay. Why is it saying Maclaurin series? Using integration. I went into the most complicated thing ever, and then I came back around to realize that e to the power of minus 5x is just, the integral is literally just minus 1/5 e to the power of minus 5x. That's it. That's all it is. So, resetting up, the limit as b approaches infinity of e to the power of minus 5b over nothing. Wait, no. Minus over 5 minus 1/5 times e to the power of 0. This still has to cancel out. This has to cancel out. And I know that because there's no possible way that it doesn't do that. We just were getting the constants wrong. I put 5 and it didn't work because I just did it backwards. Okay? This is something you want to be careful of. Integration and derivation are not the same thing, sadly. So, now, using this should be correct. Dang it, I'm wrong. Should be, so it was 1/5. I got a sign error somewhere in this. Basically, I used improper integrals to find the answer, which is 1/5. What I did wrong is I just did it backwards. I took the derivative of e to the power of minus 5x instead of taking the integral. That's all I did wrong, and this could literally take away all of your points on your test. Some teachers just literally don't care, and they will give you 0 points if you mess up a constant. With that being said, I would like to go to a more difficult problem. Actually, a lot more difficult. However, I am out of scrap paper, so to speak, so I'm going to have to copy some of this and toss it on over. I like using scrap paper because it makes me feel like I'm in a game theory video. Okay, so we have the integral from 0 to -1 of e to the power of 1 over x cubed dx. At first, this is like, whoa, what the hell? But if you step back for a second, you realize u can be equal to 1 over x, and du can be equal to minus 1 over x squared, which is going to set this up into the integral from this is going to be equal to u e to the power of u du. That's it. That's all. And you multiply by -8. That's it. So we could try to go back to x later on, or we could just say u equals 1 over 0. This is going to be our undefined term, our b, and then our -1 is going to be equal to -1. Duh! And that's going to become -1. So now we just integrate this. So using integration by parts the correct way, u is equal to u, no it's not, we have to use different variables. T is equal to u. dt is equal to du. dv is equal to e to the power of u, and v is equal to e to the power of u. Rearranging, we get u e to the u minus integral of e to the u du, which is going to be minus e to the power of u times e to the power of u. This is our final integrand. That's it. It's all simple. One round of integration by parts, very light. From the limit as b approaches 0 for on the negative end to -1. So I'm going to explain the whole on the negative end and positive end in a second. I just want to complete this problem for you guys. Now, this is worth noting. Right now, this problem, it is a-okay to put in any number. However, we're not coming from this problem. We're coming from a different problem. And in the original problem, u was not allowed to equal 0. U was not allowed to equal 0. Which means that in this problem, even though we are going to directly plug in 0, because u comes from another function, we can't do it directly. We have to use limits. This is something that you need to know. When you take integrals, or use sub, or do any of this stuff, you're going to end up changing functions so that domains are different. If you plotted the raw domain of this function, it wouldn't have an asymptote or anything at 0. However, if you tried just doing a normal integral, you will get the test wrong, and your teacher will proceed to yell at you after class. Because you need to take these limits seriously. That's why L'Hopital's rule is usually taught before this stuff even. With that being said, enough chastising. U, the limit as b approaches 0, is going to be u, or basically it's going to be approaching 0, minus e to the power of 0, or just 1. That's the first term. Now, it's going to be on the other end, minus 1 times e to the power of -1 minus e to the power of -1. This is going to become -1 plus 1 over e plus 1 over e. And this is where I feel like I messed something up. Because if you look at the answer that I'm looking at, because I already did this question, it should have been something that this cancels out. But I don't know how. The only way that that could possibly happen is if there was an extra u that was like tied to this, but then that would reset the problem. Let's see what the people did in the video, in the worked example. Again, no ChatGPT. If I use ChatGPT, you are free to report my channel for sexual misconduct or whatever, because I never use ChatGPT when I'm studying. I think it's stupid. I think it's fruit from a poison tree. This constant shouldn't exist. It has to cancel out somewhere. I just don't know where. Okay, I'm going to ignore this for now, and I will create a post explaining this. But basically what's going to happen is that you're going to get 2 over e as the final convergent limit. Okay, And then don't forget about the constant on the outside. We still had a -8. And that -8 is going to become -16 over e. Sorry about sorry about the constant. This is the final convergent answer. And what do you know? If I look at my homework, I'm not going to say I got this from where because I think that's copyright, but look at that. Directly from my homework screen, bada boom, bada bing. I am goated. If you guys have any interesting problems that you get from your own homework, I'd love to solve them. But that's all for today. How long was this? 20 minutes. Hey, I'm getting shorter. All right. Have a good day.